Hello, students. We are start our lecture 4, Theme 4, by discipline interchangeability, standardization, and technical measurements. Theme 4 is gauges. Gauges. Gauges are scaleless inspection tools at rigid design which are used to check the dimensions of manufactured parts. Measurement by gauges is easy and rapid, so they are suitable in mass production. Instead of measuring actual dimension of each part, which is time-consuming and costly, the conformance of part with tolerance specification can be checked by gauges. And we can see the difference between measuring instruments and gauges and other measuring instruments. So, measuring instruments, they carry calibrated scales, gauges without scales. Measuring instrument, they are general purpose instrument. Gauges, they are made for a particular component. Measuring instruments measures actual dimension of part, and gauges checks whether the dimensions of parts are within the specific tolerance limit or not. Measuring instrument, time-consuming and not suitable for mass production. Gauges, easy and rapid, suitable for mass production. Measuring instrument, skilled labor to handle, and gauges, no need skilled labor. Increased cost, its measuring instrument. Gauges, reduced cost. Adjustment and measuring instrument, adjustment is required, and gauges, no adjustment. So it was difference between measuring instruments and gauges and other measuring instruments. Types of gauges. Plane gauges are used to check plane, underheaded holes and shafts. Classification according to type. Standard gauge, if a gauge is made as an exact copy of the mating part of component to be checked, it is called standard gauge. A standard gauge can be used to check interference fit. It has limited application. And limit gauge. Two gauges are used to check each dimensions of the part, upper and lower limit. These are go and no-go gauges. Go gauges check maximum metal limit, MML. And no-go gauges check least metal limit, LML. These are widely used in industries. A part is considered to be good if the go gauge passes through the work and the no-go gauge fails to pass under the action of its own weight. This confirms the actual dimension of part within the specified tolerances. If both the gauges fail, it indicates that hole is undersized and shaft is oversized. Classification of limit gauges. Classification of limit gauges. Following gauges are the most commonly used in production work. The classification is principally according to the shape of pupils for which each is used. Snap gauges, plug gauges, ring gauges, length gauge, form comparison gauge, thickness gauges, indicating gauges, pneumatic gauges, electric gauges, electronic gauges, projecting gauges, and multiple dimension gauges. According to pupils, workshop gauge, inspection gauge, reference or master gauge, purchase inspection gauge. According to form of the tested surface, plug gauges for checking holes, snap or ring or gap gauges for checking the shaft. 3. According to their design, single limit or double limit gauges. B. Single-ended or double-ended gauges. Fixed and adjustable gauges. In this slide, you can see snap gauges. It's snap gauges. And plug gauges with go and no-go sides. Go and no-go sides. Next type of gauges, it's ring gauges. Go and no-go ring gauges. And length gauge. You can see length gauge. Another types of gauges, it's form comparison gauge, indicating gauges, thickness gauges, and pneumatic gauges. Electric gauges, electronic gauges, projecting gauges, and multiply dimension gauges. It was the types of gauges. Limit plug gauge. The go plug gauge is the size of the lower limit of the hole, while the no-go plug gauge corresponds to the upper limit of the hole. In use, the go end should fully enter to the part. The no-go end should not. You can see go side, go end of plug gauge, and no-go side of plug gauge. Go and no-go ends of plug gauges. Snap gauge. The go snap gauge is of a size corresponding to the upper limit of the shaft, while the no-go snap gauge corresponds to the lower limit of the shaft. In use, the go end should fully enter the part. The no-go end should not. You can see go end and no-go end of snap gauge. Taylor's principle of gauge design. Taylor's principle is the foundation of the limit gauge design. According to Taylor's principle, the go gauges should check all the possible elements of dimensions at a time. Roundness, size, location, etc. And the no-go gauge should check only one. It states that 1. Go gauges should be designed to check the maximum metal limit, MML, while the no-go gauge should be designed to check the least metal limit, LML. Go plug gauge should correspond to lower limit of hole. No-go plug gauge should correspond to upper limit of hole. Go snap gauge should correspond to UL, upper limit of shaft. No-go snap gauge should correspond to low limit of shaft. The difference between the go and no-go plug gauge, as well as the difference in size between go and no-go snap gauge, is approximately equal to the work tolerance. Taylor's principle, we continue Taylor's principle. To plug gauge goes, gauge must be corresponding section and preferably full length of hole so that straightness of hole can also be checked. The no-go gauge is relatively short and its function is dependent not only on the diameter but also on the circularity of the hole. To snap gauge, go gauge must be corresponding section and preferably full length of shaft so that straightness of shaft can also be checked. The no-go gauge is relatively short and its function is dependent not only on the diameter but also on the circularity of the shaft. You can see schemes of placement of fields, of tolerances, of workshop and inspection gauges. It's tolerance fields of workshop gauges and tolerance fields of inspection gauges. So A, it's for holes, B, it's for shafts. Tolerance field of hole and tolerance field of shaft. You can see tolerance field of no-go side gauge for holes and tolerance field go side gauge for hole, and wear limit, it's wear limit, you can see wear limit. And for the shaft you can see tolerance fields for no-go side of gauge for the shaft and go side of gauge for the shaft, and wear limit, you can see wear limit. In the table you can see formulas for determining the executive sizes of gauges. For nominal part size up to 180 millimeters and for nominal part size from 180 to 500 millimeters. For workshops gauge and inspection gauge. You can see the size of go side and no-go sides and tolerance fields for that sides of gauges. So you can use this formula and calculate the executive size of gauges and tolerance fields of gauges, of sides of gauges. So thank you for your attention. See you next time on the next lecture.